Welcome students. Question number 7 is using principle of mathematical induction show that this result is true. Now the solution is we can write the given statement as principal statement. First step is for n equals to 1. That means we are going to show that P1 is true. So for left hand side we are just going to write the first term. This is 1 into 3. So answer is 3. On right hand side put n equals to 1. So 1 into 4 plus 6 minus 1. So this is 10 minus 1. 9 divided by 3. This is 9 divided by 3. So again your answer is 3. That means left hand side is equal to right hand side. So we'll write Pn is true for n equals to 1. Second step, we assume that Pk is true for some natural number k. That means in this result, we are just going to replace n with k on both sides. Third step, we need to show that Pk plus 1 is true whenever Pk is true. First, we'll write Pk plus 1, for which we write first k term from here, right? Plus k plus 1th term, for which we replace n with k plus 1 here. So this is 2 times k plus 1 minus 1. So that will be 2k plus 1 into. If we replace here n with k plus 1, so this is 2 times k plus 1 plus 1. So this is going to be 2k plus 3. This is equal to, replace n with k plus 1 here. This is k plus 1 into 4 times k plus 1 whole square plus 6 times k plus 1 minus 1 divided by 3. First we'll simplify left hand side, for which we write our left hand side again. Now using equation number 1, the sum of these k term is k into 4k square plus 6k minus 1 divided by 3 plus last term as it is, right? Now take LCM. LCM is 3. So this is 3 times. If you multiply these two terms, we'll have 4k square plus 6k plus 2k plus 3. So that means we'll have k into this. This is 4k cube plus 6k square minus k plus, multiply this bracket with 3, you will have 12k square plus 18k plus 6k plus 9. If you simplify this, you'll get 4k cube plus 18k square plus 23k plus 9 divided by 3. Now in this question, we are also going to simplify our right hand side. Again write your right hand side. This is your right hand side. Simplify it. This is k plus 1 into 4 times, expand the square. This is k square plus 1 plus 2k plus, here you have 6k plus 6 minus 1. So that will be 6k plus 5. Again simplify it. You'll have 4k square plus 4 into 2k will be 8k plus 6k. So I am writing here 14k plus 4 into 1 is 4 plus 5 is 9. If you multiply these two terms, you are also going to have same result. That means in this question, you have shown that both left hand side and right hand side are equal. So we'll write Pk plus 1 is true whenever Pk is true. And the last line we'll write, so the given result is true by using the process of mathematical induction. Next question. Question number 11. Again important question. The question is using principle of mathematical induction show that this result is true. Now the solution is we can write the given statement as principal statement. First step for n equals to 1, for which we are going to show that our result is true for n equals to 1. Now for left hand side, we are just going to write the first term. This is 1 upon 1 into 2 into 3. So this is 1 by 6. On right hand side, put n equals to 1. You'll have 1 into 1 plus 3 divided by 4. 1 plus 1 is 2 into 1 plus 2 is 3. So if you look here, the 4 is cancelled. So we'll have 1 by 6 equal to 1 by 6. That means we have shown that Pn is true for n equals to 1. Second step, we assume that Pk is true for some natural number k. That means in this result you're just going to replace k on both sides. So here for last term you'll have k. These terms we write as it is, and here you're just going to replace n with k. So this is k into k plus 1 into k plus 2. This is equal to k into k plus 3 divided by 4 times k plus 1 into k plus 2. Next step, we need to prove that pk plus 1 is true whenever pk is true. So, first you will write your pk plus 1, for which we replace n with k plus 1 here and here also. Right? First k term we can write from this step, plus k plus 1th term. We put n equals to k plus 1. So, we will have k plus 1 into k plus 2 into k plus 3. This is equals to k plus 1 into, here you have k plus 4 divided by 4 times. This is k plus 2 into k plus 3. Write your left hand side again. Now from equation number 1, sum of these k term is k into k plus 3 divided by 4 times k plus 1 into k plus 2 plus your last term as it is. Now from these two terms you can take 1 upon k plus 1 into k plus 2 common. So you are left with k times k plus 3 divided by 4 plus 1 upon k plus 3. Next step, take LCM. LCM is 4 into k plus 3. So here you have k into k plus 3 whole square plus 4. Right? Now, write your denominator. The terms are in multiplication. So I am writing here 4 times k plus 1 into k plus 2 into k plus 3. Now simplify your numerator. This is k times. Expand your square. You will have k square plus 9 plus 6k plus 4. Now you have k times this. That means this is k cube plus 6k into 6k. 6k square plus 9k plus 4 divided by 4 into k plus 1 into k plus 2 into k plus 3. Now look at the right hand side. In right hand side, in the denominator, you're just going to have 3 factor. 4 into k plus 2 into k plus 3. But here we have 4 factor. 4 into k plus 1 into k plus 2 into k plus 3. We don't need this factor in the result. That means we'll divide our numerator with this factor. Look here. So I am dividing numerator k cube plus 6k square plus 9k plus 4 with k plus 1. So first we take k square. If you have here k cube plus k square. Now we subtract this. We'll have 5k square. This factor is cancelled. 6k square minus k square is 5k square plus 9k. Plus second factor here is 5k. So you have 5k square plus 5k. Again this is cancelled. So you'll have 4k plus 4. So in last I am writing here plus 4. That means in this case remainder is 0. So if remainder is 0, you can write this term as the multiplication of these two. So we are writing this as k plus 1 into k square plus 5k plus 4 divided by these 4 factors. Right? Here k plus 1 is cancelled. Again by factorization method, you can factorize this. You will have k plus 1 into k plus 4 divided by 4 into k plus 2 into k plus 3, which is equal to your right hand side. So you have shown that pk plus 1 is true whenever pk is true. So that means by using the principle of mathematical induction, the given result is true for all natural numbers.